So if you just have like x equals 3, then the line is just flat like that. If you have like, actually, or like y equals 3, sorry. If you have like y equals 3x, then it just is got a tilt to the line. It's got a slope, right? If you have like y equals x squared, then you get a curve in it. If you have like y equals x to the third, do you remember how I said there were 2 turns in that kind? Is that ringing a bell? You picking up what I'm doing here? Y equals x to the 4th kind. There can be a lot of other stuff after it, but if it's to the 4th, there'll be 1, 2, 3 turns. Okay, and then if this is like y equals not 5, x to the 6th. Oh, wait, my bad. My bad, it is 5th. And that's degree. It's the biggest power. That's degree 5 would have 1, 2, 3, 4 turns. This ringing a bell? Remember this stuff? Okay. So then why would all of these, every one of them, they never go down on the right? Did you ever notice that? They're always going up on the right. Why? How could we have known that by looking at their equations? Okay, focus. Why are they all going up on the right? Yes? None of them have a negative in the front. There was never going to be a negative in front because they were all up on the right. See? Up on the right, up on the right, up on the right. That one, I guess, is kind of, well, it's not down on the right anyway. Okay, so let's get into this. Would you please multiply this thing out, but not all the way. We'll save you some time. Just multiply out the biggest powers. So like that, don't forget it's squared though, times that. See, it saves you a bunch of time. There'd normally be 4 parts to this problem. We just need you to do 1 part. Actually, to do this all the way out, you would have had to take this and times it all by itself. It would have taken forever. But instead, you should know the lead term already. Would you please circle it? And remember, you have to multiply that times, or put it to that power, and then times it by that x. And let's say that you think the answer is 4x to the 3rd. It's not, but let's say you thought it was. Would you please compare that to the kid next to you? See what they think. If you're stuck, help them. All right. I know some people screwed this up. That negative 2 squared, that's positive 4. Then you got the x squared, that's x squared. And then you got to times it by this x. Final answer, 4x to the 3rd. I didn't think I had it right, but I actually did. Process that for a second. I know some of you thought, but it was just a negative 2. But that negative 2 got squared. Yes?
If you do the 2 to the negative 2x, I thought that was negative 2x to the 3rd.
Okay, but this has to be done before you do that. The fact that it was squared meant that that part had to get done first. So, bottom line, I've got the right answer here, and I had to do this part last, and this part first, and that part gives me negative 2x times negative 2x, that's what squared means, which makes positive 4x squared. Then you times it by another x, 4x to the 3rd. All right, so then now that I see that, the right side will be up. Truckee, why is the right side up? Yep. Why is the left side going to be down? Because it's the opposite. Because why? Because this number here is odd. If that number is odd, then it's going to be the opposite. And so it's opposite of up is down. Okay. There was a lot of people got that wrong, so let's try that one more time because this is going to be something we test you on. X squared plus 3, and you don't have to write this all out. You just have to do the problem. negative 3x plus 1 quantity squared. Just the lead term. That's the lead term here. That's easy. But then there's this. And what would be super easy to forget? That little squared right there. All right. Matisse, tell me what you think the final answer is. 9x to the fourth, and she's got it. This one would be 9x squared, but then you times it by this, and that makes another x squared, and that makes 9x to the fourth. Who had 9x to the fourth before she said it? Okay, good. All right. Now that's the lead term. Since it's positive, on the right, it'd be up. On the left, should it be the same or different, Max?
It should be different.
All right. Because why?
Because it should be, sorry, I thought that was a 9.
That's what I'm doing right now is I'm cleaning this up to make sure it's more clear. Now what do you say?
Now it should be even.
It should be even and therefore the same or different than that.
The same on both sides.
There you go. Does that make sense? Why? Because that's even. If it's an even degreed polynomial, both ends are going to be the same way. And since we already knew it was up, it's up and up. Okay, now here is our next step. This is telling me that x equals 2. Do you remember finding solutions like that? And this is telling me that x equals negative 3. Everybody put a dot at 2 and at negative 3. Why? Because those are the x-intercepts. Next, I can look at this thing and say, if I multiplied just like we were just doing, this times this, I'd get x squared. So the lead term's positive. So that tells me everything. The lead term's positive and they're both the same because it's even. So they're both up. So I know that it has to be up on both ends. So I know this polynomial needs to go like this. And do you guys remember it's just a quadratic? Do you get it's just going to go like this? It's just a U shape. So am I just overanalyzing it? I don't think so. You're going to need to know the lead term on every one of the problems on the test. Because you'll always be checking for, is there a negative? Because if there is, the right side's got to go down. All right, so let's look at this one. There's 3 answers. Any small child can tell me that this is 7 and this is negative 9. But that one's trickier. Got it? Yes. I'm going to say 3 over 2, which is the same as 1.5. And for those that have trouble doing these in your head, I'm just going to say set it equal to 0. Add 3 to both sides, and I get 2x equals 3, and then it's pretty obvious that it's 3 over 2. So that's just solving a little equation that you can make. Set this equal to 0, set this equal to 0, and set this equal to 0. And you get your 3 answers. 3 over 2, like you said, 7, and negative 9. So then, I want you to now translate that into, the 3 x-intercepts. Go ahead, put them on dots. Over here on the graph, put those 3 numbers, negative 9, 7, and 1.5. Put them as dots. I think some of you are still drifting from lunchtime. Get focused. We'll get this done with, and then you can relax a bit, but I need your full attention here. Graph those 3 things, negative 9, 7, and 1.5 on this number line. Connor, you got all 3 on there?
Not yet.
Okay. 7. 1, 2, 3, 4, 5, 6, 7. And negative 9. I think that's negative 9. And then 1.5. It's like right there. Now, do you get there's 3 dots? This cannot be a parabola then. You know what I mean? It can't just be like this. It's not possible. It has to hit all those dots. So I need to know my ends first. So I multiply this out. That times that times that. 2x to the third. Notice, no negatives. So it's up on the right. And is it the same or different? Different. Up on the right because it's positive, but different. Oh, so it's up here and it's down there. Do you get what we're going to do now? If it's up on the right and it's down on the left, I knew because there was no negative in the front, so it was positive. That meant it was going up here. And I knew because the degree was odd that it would have to be different. Now I just go like this. Ka-took, ka-took. That's how the graph would go. Has to go through those 3 blue dots. Has to be 2 turns, remember? Because it's x to the third. There's 2 turns. Some of you might have noticed this just got harder. Last couple days have been pretty easy. See if you can hang with this. Whenever you see this, you just have a single root. This, do you see why the word double comes in? It's because of this. And you see why the word triple comes in? It's because of that. So I'm going to show you what those look like. There's this fancy word multiplicity. I kind of don't like it because I kind of like to keep life simple and not use complicated language if I don't have to. The multiplicity is kind of like the degree of that little term. It's 1, 2, and 3. It's just that number. That's called its multiplicity. Okay? So the nth root has a multiplicity of n. It's whatever's there. And that just means we don't know what root we want, so we're making up a variable and putting it there. But if n is odd, then it'll be different on both ends. And if n is even, no, that's different. It's something else. Let me show you something. This one will have a root or a 0. We've decided to call them zeros this semester. They sometimes are called roots in other classes, but just so you know, we're going to call them zeros. The 0 here is x equals 3. Its multiplicity, that we're just going to call it an m, is 4. And then that means it's not one of the big ones. As soon as you go beyond 3, then we just say that it's even. Degree. All right, this one, the 0, is -1. Because if you stick a -1 in here, it'll make it equal 0. This side, the stuff inside here would turn into 0. Okay, so -1 is the 0. The multiplicity, if you want to write out multiplicity, more power to you. I have seen some teachers call it MPY for multiplicity. The multiplicity is 2, and that is called a bounce. I'll show you why it's called a bounce in a second. And last but not least, the multiplicity, the 0 here, I can do in my head. It's x equals 2/5. If you're not good enough to do that super fast, I'll show you. You'd go 5x minus 2 equals 0, 5x equals 2, x equals 2/5. That's how I got it. Its multiplicity is just the power. Say it if you know it. Come on, what's the multiplicity of this one? 7. It's just that. And then this one is an odd degree. What do we know about odd degrees? Well, that they make things do things that are different. The ends are different. But here, it's called a snake. This will snake. What is the snake you're talking about? All right, so let me show you a picture of on a graph. On this one, immediately I go to 5, put a dot. You know why? Think about why I'd put a dot there. Do you get it's the thing that made the first parentheses 5? If I put a 5 in there, it'll make it equal 0. Does that make sense to you? Okay. Then what should be for this? -1. So I put a dot in -1. Next thing I do is I always go figure out just the first term. I don't have to multiply all 4 parts out and say it's like x squared minus 4x minus 5. I just need the first one. That times that, x squared. And that tells me everything. The right end is up. This is even, so they got to be the same. And then cool, it just has to go through here. And it's not doing something called a bounce or a snake. It's just simple. Let me show you what would have happened if this 5 would have had a squared right here. If that 5 would have had a squared, then our total degree would have been a 3. How would you get that? Because if I multiplied this x squared by another x, then my lead term is a x to the 3rd then. And that means it's got to go down on the other end, and watch what happens. This is called a bounce. It goes up, it bounces off of it, and then it goes down. That's called a bounce. This is called a pass-through or a cut-through. Have you ever heard of like, I'm going to cut through my neighbor's backyard? It means like you walking through it, okay? So this is a cut-through. I've been told that more people maybe use pass-through, so I'm going to use both words. Okay. So if it gets squared, you're going to make it bounce. If it only has a 1 here, it's just going to pass through. What if there was a 3 here? Then it would snake through. And I'll show you what that looks like on a different one soon. Kind of looks like a snake, obviously. All right. Would you everybody go to this one right here? Truckee, can you shut that door for us, please? Thank you. Everybody start by graphing the 2 zeros. There's 2 things that would make this equal 0. -1 and 5. If you haven't already figured it out, it was -1 and 5. But at the 5, we've got a multiplicity of 3, so we call this a snake. Let me show you what that looks like. And if you have trouble drawing one of these, I'd be fine with you just writing snake. It's supposed to look like an x to the 3rd graph. Do you guys remember what x to the 3rd looks like? It kind of looks like this. That's called a snake through. All right, now I'm going to go through, and this is to the 8th. Even ones bounce, odd ones snake. It could be 18 instead of 8. It could be 22. Any even one will bounce, and it looks like that. There, I'm done. See See how fast it was to graph that thing, actually? Now, is that a super accurate graph? No. We'd have to actually stick in numbers, just put in a 0, see what you get. Put in a 1, see what you get. Put in a 2, see what you get. But the only one that's super important is the y-intercept. The y-intercept is where x is 0. So you put in a 0 here, and you could figure out what the y-intercept is by going -5 to the third. Oh, that's gross. It's -125. And then 1 to the 8th is just 1, and so the y-intercept would be -125 times 1, which is just -125. All right, so this scale is really weird. That's theoretically -125.
So if you have an exponent, it affects the x-intercept number?
The y-intercept number. Yes. All right. Let's go back to this one. The snakes are really weird to draw. But see if you can draw this one. You should know what the 2 zeros are. It's been the same on the whole page. You should know whether it goes up or down on the right. You should know if it goes up or down on the left from if it's the same or different. So very first step would just be this. See what your lead term is. Because it tells you so much. I'll pause for a second while you figure out the lead term. Put a couple dots on the zeros. One of them's a bounce. And see if you can make the sketch of the graph. So I hope you knew that this was x squared and another x made x to the third. How many of you used that? Good. That's something you should do every time. And then if it's positive in the front, we know it goes up on the right. If it's odd, you know it's always different. And so therefore, in this case, down on the left. The two key spots were +5. Oh, I missed it. 1, 2, 3, 4, 5. And -1. And now I just have to follow all those rules and watch me do it wrong on purpose. You can't do that. I just made up a whole nother root or 0 or x-intercept. It can't be right. But yet I feel like if I have to go down here and I have to go up there, it's just not working. What am I not doing? Yes?
You have to like bounce.
You have to bounce. Remember the 2's are bounces? I have to bounce at the 5. So as I'm drawing this across, I do start where I was starting, down here. But when I hit the 5, I gotta bounce off the 5 and then go up. And what I say was the only other point that we're gonna make you find. It's called the something something. Yes, the y-intercept. Okay, and the y-intercept is where x equals 0. You'd stick in a 0 right here, and you'd have -5 squared, which is 25, and then a 0 here, and then times 1, so just 25. So that is 25. And you might be like, that looks like 1 to me. You can make the scale anything you want. So apparently each box is going to be 25. So this was 5, this was -1, and that's 25. That is a typical test question. So let's take it again from the top. Act like I hadn't taught you anything. So you'd be looking at this problem and you'd be going, oh, I guess I'm supposed to graph this thing. And would we be able to use a calculator? No. Because the calculator, you could just type it in and it would show you exactly what it looks like. So we want to know if you can graph them with just your brain. So you'd go, okay, I remember 5 is important. You'd put a 5 on there. I remember -1's important. Put a dot on there. Then hopefully you'd remember to find this. That was the lead term. And since that's positive, you'd know it was going up. Since it's odd, you know that it's going down on the other side. And then you had to remember that the multiplicity of 2 gives you a bounce there. That's why this is a bounce. And that's how you make a graph like this. That's a lot of steps. This is going to definitely separate out the A's and the B's. And some people might be able to tell me that 5 and -1 are a big deal and that it bounces. Excuse me, but they probably won't be able to put it all together. I hope you will. Everybody try that one. Just try that one by yourself. See if you can graph that. It does something different than all the other ones did. I'll pause for a second. Well, you find the lead term. Figure out if it's going up or down on the right. Up or down on the left. Figure out where it's bouncing. I'll pause. So, this one had a bounce at -2, a pass through or a cut through at 5. See, the 5 didn't have any weird power. So it just passes through. It was up on the right because this was positive. It was down on the left because this was odd and therefore it needed to be different than the other side. Okay, I've taught you almost everything, so let me just fill in these last couple things to take notes. If a factor has a blank multiplicity, well, I'm going to just say a 1 multiplicity. That's kind of like this. You know, the multiplicity is this power up here. Then it will blank at the x-intercept. Pass through. You can abbreviate it THRU. 4 letters means through. If a factor has a blank multiplicity, let's say a 2 multiplicity, now you should be able to know the next word. Then it will blank. Say it. Come on, don't be shy. If it's got a 2 multiplicity, then it will what? Bounce, thank you. And if I had a third one, a 3 multiplicity, do you guys remember what 3 goes with? Snake. You guys better write these down because not many people are answering, which makes me think maybe a few of you know it and you're just being coy, but I think a lot of people don't know. 1 is pass through. 2 is bounce. 3 is snake. So if I had this, do you get that one of these would snake through and one of them would bounce? Do you get there's no negatives on the lead term, so it must be positive right on the right side? I mean, going up on the right. So I'm going to graph this super fast. Watch how fast I can graph this. I'm still explaining it, which will take longer, but it's got to hit 8, and it's got to hit -4. It's got to bounce at the 8, boing, and it's got to snake through the -4. And I get those are hard to draw, so I just compensate by writing snake. Everybody can make things bounce, and you don't have to say it, but if you wanted to say bounce, you could, but you don't have to. And then you get the y-intercept by sticking in x equals 0. This one would be huge. It'd be a pain to figure out because the numbers are so big. 4 to the 3rd and -8 squared multiplied. Holy crap, that's immense. You wouldn't have to do one that big because you wouldn't have a calculator on the test, and we don't expect kids to get giant numbers without a calculator. So there, I've taught you everything. Now, will you get it? Time will tell. We're not going to make you graph many today. A lot of it's just like, tell me the x-intercept, same as the 0. Tell me the multiplicity, which is like bounce. No, wait. Behaviors. Here, let's write these out. This is bounce or snake. or pass through. This is like 1, 2, or 3. This is a multiplicity. And the x-intercepts, those are these three guys. All right, so I'm going to put them in order so that we can all be the same. The x-intercept of the first one's -7, of the second one is 2, and the third one is -1/2. Would you please finish by getting these 6 things? We're almost done. Stay with me for 5 more minutes, and then you'll be out of here. Parker, tell me the multiplicities. The -7 has a multiplicity of 1 is correct because there's a 1 right there. Okay, multiplicity for the 2 is 5, and the multiplicity for the -1/2 one. Excellent. Do you remember what 1 does?
Yeah, it passes through.
PT, pass through. How about the 5? That's a snake because it's odd. A 3 would have been a snake, so is a 5. And the 8, bounce. Anything that's even will bounce. That's how you do it. I know that's a lot. If you're trying hard, it's all I can ask out of you. And you will get smarter between now and when we take the test. Just got to practice this. All right. I can look at this and say it's even. You know how I know it was an even degree? Yeah. Yeah, they're both going up. That meant it had to be even. Was the leading coefficient positive or negative? I can tell. Parker, can you tell?
Yeah.
What was it?
Positive.
It was positive. Why?
It goes up on the right.
Because up on the right. You got it. Do these have x-intercepts? Truckee, give me an x-intercept.
-1.
Yep. Give me another one.
2.
Yep. Give me the last one.
Oh, -3.
Yes, those are the 3 x-intercepts. And a possible equation. Oh, man. Would you have anything this hard? Maybe. That's probably what I'm supposed to teach you tomorrow. I'm putting a parenthesis for each root. Then I want the answer to come out to -1, so I'm going to go x minus 1. Do you get out? No, wait, x plus 1. Do you get how a -1 would make that equal 0? And for this one, this 2 here, I'm going to put x minus 2. And for this -3 here, x plus 3, because then a -3 makes it equal 0, and they're called zeros. So those are kind of counterintuitive. Remember, you don't trust the stuff on the inside? On the inside, you would have expected they'd put a -3, but you don't. You put a +3 because it's on the inside and everything's backwards. Okay, and then last but not least, it's bouncing here at the 2. Bounces. Snaking here at the -1 to the 3rd. I think some of you could have figured that out. On the 3, it's just passing through. I could put a 1 here, but I don't have to. Any part of this you want me to try to explain? I recognize the snake as this -1 right here. This was the snake, so I knew it had to be an odd power. I put a 3. It's possible it could be a 5. I can't tell really. The most asked question about these on our last test was, what's degree, Mr. Server? If I multiplied this all out, this x to the third, this x squared, and this x to the 1, that would make the lead term of y equals x to the 3, 4, 5, 6. That means this is degree 6. That's all of those lead terms getting multiplied out. Gives me one boss lead term. And that tells me it's up on the right. It tells me both ends are going to be going the same way. It tells me it's degree 6. Yeah, that's pretty much everything. All right. So you have a worksheet, and somebody pull that worksheet up, and I'll tell you which problems you can skip once I get a chance to see it. If all of you would pull it up now, I'd appreciate it. Pausing for a second. So on today's assignment, you may skip number 2 and you may skip number 4. Why? Because they're terrible problems? No, there's just 4 problems that are like it. So we don't need that many for practice. So that'll cut it down to a more reasonable size. I know I just gave you a lot. So if there's questions, please come on up during the work time. I'll be happy to help you. We will practice this more, but this is what your next test is like. So if you're struggling with it, ask.